This video on angles looks at quadrilaterals. The first video looked at straight lines, triangles and parallel lines. This will come up when looking at quadrilaterals. Quadrilaterals get four straight sides. Any quadrilateral can be split into two triangles by drawing in a diagonal. Each triangle has an angle sum of 180 degrees, so because there's two of them in a quadrilateral has an angle sum of 360 degrees. That is, the four angles at the corner add up to 360 degrees. This quadrilateral has no other properties other than that angle sum. If, however, I was to give it some extra dimension to it, such as make a pair of opposite sides parallel to each other, this is now a trapezium. Because we've got parallel lines, we've got some properties that come with parallel lines. If you have a diagonal drawn in, you can make a Z shape. Alternate angles with parallel lines are equal. So these angles in a Z shape are equal. And if you drew in the other diagonal, you get another pair of alternate angles. And that would be extra properties that in general quadrilaterals don't have. If I was to then say make the opposite sides not only parallel but equal in size, it becomes a parallelogram. So a trapezium where the opposite sides are not only parallel but equal in size is a parallelogram. Because I've made these two opposite sides parallel and equal, when I join up the ends, the other pair of sides are also parallel to each other and equal. This gives more alternate angles. You've not only got the Z shape around the diagonal we had before with the trapezium, you've also got it with the left and right hand side. There's another Z shape there, and of course you can do that with the other diagonal. Second thing is, in the parallelogram, the diagonals half each other. They bisect, they half each other. So you get more properties simply from this extra dimension to it, that the opposite sides are equal and parallel. If I was to make, for a parallelogram, all the angles at the corners 90 degrees, this parallelogram is called a rectangle. Not only do the diagonals half each other, they're equal in size as each other, so you end up with the diagonals making equal quarters when you draw the two of them in. And you get alternate angles being equal as in the parallelogram, but because the diagonals are equal in size and have been halved, you get isosceles triangles involved. So you get more properties. If you were to make not only the angles at the corners 90 degrees, but make the sides all to be the same, the rectangle here is a square. So a square is a rectangle, but where all the sides are equal. When that happens, you've got even more properties. Now you could do the same with triangles, like an isosceles triangle on the top, and put an isosceles triangle on the bottom there, and using isosceles triangles, we've got a kite. And if you make the triangles identical to each other, you've got a rhombus. So a square is even a rhombus where the angles happen to be 90 degrees, but as long as the isosceles triangles top and bottom are identical, you'll have a rhombus. A rhombus is also a parallelogram. So a rhombus is a kite, a rhombus is a parallelogram. A square is a rectangle is a parallelogram. They just get extra properties, we give them a special name. So considering triangles, if I was to take two isosceles triangles with the same size of base and place them together, I make a kite. Because of the equal angles in the isosceles triangles, there they are in the kite, and then the left hand angle and the right hand angle in the kite here are the same. The green diagonal is being halved by the blue diagonal. The blue diagonal is a line of symmetry, so lots of extra properties. Here are two identical triangles. The top triangle is rotated 180 degrees to give you the bottom triangle. If I put them together, you make a parallelogram. And if I take two triangles here with these red sides there, the same size, and put them together, I can make a trapezium. So you can think of these shapes as triangles put together. So here's a trapezium. It's got no line symmetry, it's got no turn symmetry in general. This is a special case. But because it's got parallel lines here, these two angles A and B are supplementary. They add up to 180. That was meant in the first video. The inside bit of an F shape. And C and D on this side, they make 180. Altogether, the four angles make 360, but the ones on the left add together to make 180, and the ones on the right add together to make 180. But you can't relate the red angles to the blue angles. If you were told any of the red angles, it doesn't help you get the blue angles at all. You have got alternate angles. These ones marked O, they're equal. These ones marked here X, the other diagonal, they're equal. They're alternate angles around parallel lines. So to put some figures on them, given that's 130, you'll know this angle makes it up to 180. Given this is 70, you know this angle will make it up to 180. Altogether it makes 360. 180 on the left, 180 on the right, but there's no connection between the left and the right. Knowing the left doesn't help you figure out the right. Alternate angles in the Z shape, alternate angles in the Z shape. Again, knowing this 30 doesn't help you get the 40 in any way. Again, make these two sides parallel to each other, make them the same size, and you've got a parallelogram. It's now got half turn symmetry. So if you rotate 180 degrees, the top part fits onto the bottom part. That makes these two opposite angles equal. And these two opposite angles equal. So opposite angles are equal. Angles next to each other, the allied angles, they make 180. That was the case for a trapezium. In the trapezium you had the angles marked O here equal, so that was the case for a trapezium, but extra for the parallelogram, the ones marked with the star are equal because you've got these pair of sides equal and parallel. The fact that these two sides are equal and parallel, when you join up the ends, it makes the other two sides equal and parallel. So you've got more alternate angles. There they are around the other diagonal. Now, if I was to put both diagonals in the same diagram, the diagonals half each other. The diagonals are a different size, but they half each other. Again, you can work around the red diagonal to get these angles in red, and you can work around the blue diagonal to get the angles in blue. So as to put figures to them, that's 70, opposite 70, and next to the 70 is the allied angle making up 180. So you get all the angles next to each other, they make 180, even across here, because the inside bit of an F shape, opposite angles equal. Altogether they make 360. That's 20. Simply matches that being 20. That's 35. Alternate angles. If I put the angles together there in the one diagram, you can now see that you can get the angles in a triangle making 180. So you can work out these two angles. And then straight lines here, 125 and its supplement. That gets you these two at 55. But there's no way to work out these two on the left or these two on the right. Notice angles on the top are repeated on the bottom but rotated 180 degrees. So no way to work out these other missing angles. When you make the four angles at the corner of a parallelogram 90 degrees, you've got a rectangle. Like a parallelogram, it's got half turn symmetry, but it's also now got line symmetry, which a parallelogram didn't have. A vertical line of symmetry and a horizontal line of symmetry in this case. And the diagonals are equal in size. The two diagonals are the same size as each other, and they half each other like any parallelogram, so you get four equal parts here, and it gives you an isosceles triangle on the top and an isosceles triangle on the bottom, an isosceles triangle on the left and an isosceles triangle on the right. The ones top and bottom are identical, the ones left and right are identical. Now if you were given one angle, you can work out all the other angles. So to put figures to it, if that's 25, you've got the alternate angle, and you've got the fact there's a line of symmetry vertically through the shape. Or alternative, you can think of that as an isosceles triangle with two equal angles at the base. Next you can make the triangles up to 180. And now you've got the top triangle and the bottom triangle. You can get, I'll put down this in the other diagram, you can get the supplement here at 50 degrees to make a straight line up to 180, and the complement in here to make the corners up to 90 degrees. So using that, I'll put in a separate diagram just to avoid clutter. There's this 130 and its supplements 50, and there's the 25 and its complements 65, and there are isosceles triangles here, identical left and right, so you can work out all these missing angles. So given one angle, you can work out all the other angles in the rectangle. And the square is just a rectangle where the sides are all equal. When that's the case, the diagonals not only half each other, they do so at 90 degrees. There's a right angle between the diagonals, and the angles at the corners are halved, bisected. So they're 45 degrees, all the places marked with a little cross. So there's nothing more than to show for a square, because as soon as you know it's a square, you know the angles are all 45 at the corner when the diagonals are drawn in. You know the diagonals make a right angle with each other. So that's a trapezium, could turn into a parallelogram, could turn into a rectangle, could turn into a square. If we now think of isosceles triangles, you put two isosceles triangles together when they've got the same base and you get a kite. So there's an isosceles triangle on the top, two equal sides, two equal angles, and on the bottom, same setup. So that will give you angles at the top and the bottom. If you put in the other diagonal, it's a line of symmetry right through the shape. So the angle on the left here is the same as the angle on the right, and the angles at the top get halved, bisected. So, and the angles at the bottom the same, they're halved. So that's because that red diagonal is a line of symmetry. Because it's a line of symmetry, it bisects, halves this diagonal, the blue diagonal, at 90 degrees. So it's the perpendicular bisector of the other diagonal. That gives you two right angled triangles on the top that are identical, and two other right angled triangles on the bottom that are identical. If we put figures to these, that's 50. This is an isosceles triangle. It's 50 over here, and you can make the triangle up to 180. After that, you're stuck. You can't put anything in the bottom, so you don't know anything about the bottom angles. However, if you look here, this is 120. It must be 120 on the other side, because that's a red line of symmetry there. That's 20. It must be 20 over here. And now you know the triangle here, 120 and 20. You can make the triangle up to 180, both left and right. So that's the triangle on the left makes 180. One on the right is its mirror image. It's identical. Here, that's 20. So it's 20 on the other side. There's right angles here between the diagonals. So you know that's 70 to make the triangle up to 180, and it's 70 obviously over here. So that's the bottom done. You can't fill in the top. So there's no way to use this information to help you fill in the top. You don't know anything about the angles on the top. That just depends on the triangle on the top. So that's a kite. It's got no turn symmetry, but it's got that diagonal here. There's one line of symmetry. Now if you get a special kite, we're making the top triangle identical to the bottom triangle. You've got a rhombus. So the top isosceles triangle and the bottom isosceles triangle are identical. That means if you're given one angle, you can not only work out the top, you can work out the bottom, because the bottom's the same. This is as in the kite. The left is the same as the right, because that's red line's a dotted line of symmetry. But then the blue line's also a line of symmetry. So top and bottom are mirror images, and left and right are mirror images. Two lines of symmetry. Each diagonal halves the other at 90 degrees. one right angle triangle on the top is identical to all the other right angle triangles. So it's got half turn symmetry, which a kite didn't have, and it's got two lines of symmetry, which a kite didn't have. You've still got the allied angles as you had around the parallelogram, because it's got opposite sides equal and parallel. So it is a kite and it is a parallelogram. So a rhombus is a kite and it is a parallelogram. It's got all the properties of a parallelogram, it's got all the properties of a kite, and that's what gives it lots of extra properties. So putting figures to these, that's 70. Isosceles triangle on the top. Could do that before with a kite, but the bottom's identical. So you can fill every angle in. 140 here. That's 140. Allied angles make 180, so it's 40 up the top here for the whole angle. 40 and 140 make 180. That's a property of a trapezium. So this is a parallelogram. Parallelograms, special case of a trapezium. Trapezium, the allied angles make 180. And at the top, the angles get halved, so when that's 40, it's 20 and 20. And the bottom is identical to the top, because this blue line here, this diagonal, is a line of symmetry. So the bottom and the top are the same. So given one angle, you can get all the angles. Same here, 70, 90 at the corner, going to be 20 up the top. And then every triangle's like that. All four triangles are identical. So a rhombus with the top triangle is the same as the bottom triangle. Given one angle, you can work out all the angles. So that covered all the shapes. If you click the link description, it's a worksheet where there are rectangles, parallelograms, kites, rhombus, no trapezia, and the squares just put in among the rectangles there. The answers will be on the sheet. There are just lots of questions, and basically it's you just fill in all the angles possible, which means every angle. So lots of questions, rectangles followed by rhombus, followed by kites, followed by parallelograms, followed by all the answers. And there's a set of notes. If you click the link in the description, you get access to the notes. That was the first video on angles. That's what we've just covered there, quadrilaterals. It summarises properties, not just about the angles, but about the sides. Next video is on circles and their properties. Hope you found this video useful. Thank you.